Hey everyone, welcome to another video. It's been a long time since I posted a video to this YouTube channel. I wanted to revisit one of the repos, which was the gait analysis using DeepLabCut. So in that repo, I showed how to use DeepLabCut's foundational models to do gait analysis. Um, I next learned a few extra things and I then wanted to update it. And by that time, I was already starting to use more of the YOLO-Pose side of key point analysis. So that's what this repo is about. I have done key point estimation with YOLO, and that's what I want to show here. How do you use YOLO pose estimations to do gait analysis? In this specific case, it's going to be for quadrupeds. In my particular case, I will be using mouse videos to do that. So I want to acknowledge a few things off the bat. I am carrying over a lot of the code from the previous repo, and I have gained inspiration for this repo from a lot of the talks that I watched and listened to this year as well as last year from APS March meetings, specifically the animal behavior and social interaction talks. I don't exactly remember all of the presenters' names, but those of you who were presenting at APS and were talking about gait analysis in some way, shape, or form, please be sure that you guys did some great presentations and some great information was shared to the point that I was inspired enough to come back and figure out how can I use gait analysis to basically interrogate uh, brain and to learn what how does gait inform us about what's happening in the brain. So as a way of explanation, so again, this is a very simplistic view, and this is also available here. You can go to this page uh, right here and then click on this link, and it will take you to this HTML file. Uh, I work with animals and in a lab where we study exposure derived metrics. So exposure, inhalation exposure, how that changes the peripheral nervous system as well as the central nervous system. So in some context, the gait is informative to study because it can help us understand brain centers. The brain centers, specifically the three that I've mentioned here, the motor cortex, basal ganglia, cerebellum. Now, it's not going to tell us exactly, what mechanisms are involved, but at least it will point us in the right direction so that mechanistic studies could maybe focus on certain regions more than the others. So simplistically, what I want to say is, suppose somebody is exposed to solvents for a long period of time. Let's say you're a dock worker or you build houses or you're a carpenter and you're exposing yourself to solvents like toluene a lot of the time. And then over time, what kind of gait pattern one would expect to indicate some kind of a damage in the brain that might be going on. Very simplistically, so I'm not going to go into detail. Again, all of this is here super hyper simplistic, just for sake of representation and to help maybe understand how does gait inform what's happening in the brain. So exposures, where does it come from? Could be olfactory driven, you're inhaling, could be oral or through the lungs. You get exposed and it becomes systemic route. But overall, things get into the brain and they cause damage. In this case, solvents, there's a lot of literature showing that cerebellum gets affected. Cerebellum controls fine motor movements, balance, coordination, those type of things. But how does that uh, from the brain, how does that get translated to the limbs is through the CPG networks or central pattern generating networks. And that's something that I didn't really know. Okay, so maybe I learned that in neurobiology at some point, but I didn't remember. So some of the APS March meeting talks were so informative. I was like, okay, some things are coming back, but maybe not all of it. So the visual payoff is that by analyzing gaits of the animals, the coupling strength between the coordinated limbs, you can learn a lot about what is happening and what brain regions might be involved uh, by way of referencing your dysfunctional gait to a functional reference gait. And that's what's shown here in panel 4. Now again, this is very simplistic. It's just for sake of visualization to make it easier to visualize and to understand what might be happening. I do have some references over here for all of the different exposure toxicants that I've used here, metal particles like this. It's hard to even fathom that we are inhaling metal every time we go out. Metal particulate matter comes from exhausts, cars, all kinds of different places, but we're all exposed to those particulate matter basically all the time, including solvents. I mean, formaldehyde, for example, is everywhere too. Okay, so anyways, I'm gonna go off topic if I continue with this train of thought. Coming back to the Ultralytics YOLO-Pose, let's go over the code itself. So I've already ran this project once. This was to make sure that everything runs and that I'm not going to make a blunder out of this video. So what I'm going to do is I'm going to show you the video I'm going to run. This is a representational video from the top-down view. If I was to do this gait analysis for real, for a lab experiment or for like some kind of a project, I would want to capture the mice from the bottom perspective to capture their paws. Now from the top down, we can still use the shoulders and the hips as a reference point for where the paws should be. And as those hips are going to move along and shoulders are going to move along, we can use that as a reference point. But it's not accurate, so therefore don't assume accuracy in this YouTube video session. And then I have developed already a profile for the experiment that I'm about to do. You can set this one up at the beginning of your run session. So for example, here I am showing you can create a reusable runtime profile by running this command. Okay, so the first time that you do this, it's going to ask you the video input path, the input labels directory, left paw index, right paw index, and this is all assuming that you are using key point configuration that are different than what I'm using. I'm using a 12 key point default configuration for this entire repo. So I'm not presuming that everybody's going to be using the same index for each of the key points. Therefore, this will allow you to change that via the command line inputs. If you don't want that, you can go directly to the config file. You can come here to the configuration file and just select these by yourself. So if you're comfortable doing that, please go ahead and do that. This is the easiest way to utilize this. So apart from this, there will be ROI config file that gets generated on the first run. So let's go ahead and run this. So this is asking you now, what kind of ROIs do you want? Oh, I misspelled it. So let's close this down. I misspelled it. So okay, it didn't save, but you get the idea. I misspelled my arena. I called it arima, and I closed everything down. So the idea is that on the first run, it's going to ask you to draw the ROIs if you want the ROIs. If you don't want the ROIs, press enter and continue. There will be no ROI-based analysis done for your run. And yeah, okay. So a few other things. I'm going to go ahead and run YOLO-Pose on the video that I have. So this is the video it's running. Again, I'm using those shoulders and hips as the proxy for where the paws are. Okay, so that ended up running well. And this is where the predictions are. I'm going to move them up just one folder up. And you can change where your paths are via these two lines here. So line 10 and 11 for me, And this is where my video is. And I'm using auto detection for my labels using the os.path join over here. So this way I don't have to continuously input the labels path all the time. Okay, so video has been run through YOLO-Pose estimation. YOLO-Poses have been generated in the prediction. So this is where these are the key points, and those key point estimations are saved here in these txt files. Now I'm going to run the main.py. So no ROIs were there. I'll just call it R1 for now and put a bounding box like this. This is going to be my arena, and I don't want any other ROIs, so I'll just press enter and continue. For me, this was really fast because it's only a 20-second video. The results are where everything gets saved. It will output video segments where it identifies a specific pattern of gait happening. Like here, it's a mixed gait. This one is a bound pattern again. So stuff like this gets outputted, and of course this Hildebrand diagram is used as well from the previous implementation of this repo that was done with DeepLabCut. The summaries are stored also like this HTML file that you see. It's a very quick view of your entire data, but this is not all of your data. All of your data itself is stored here in these Excel and CSV files. Another representational view is through this HTML file, which gets which shows you stuff like this, and you can change these reference patterns depending on what kind of whatever type of stuff you're trying to do. For me, these are mostly for sake of presentations. Suppose I want to present to at lab meeting, for example, and I want to have a reference pace diagram over here on the left, and then the measured movement, and show how these two are relatively different from each other. This would be something that I would take a screenshot of or record and show that. And then as you play, these things also change, and you can of course slow this down for sake of seeing and for sake of demonstration. Down here, these are all locked in with the whatever reference frame that you pick over here. On the left is the selected reference, on the right is the measured movement. Again, these are sampled from your actual data set. These are not going to be entirely representative of all of your data per se. And then same thing over here at the bottom. Okay, so I hope this will help at least somebody. And this is all available here on the GitHub under Gait Analysis YOLO. Do leave me your comments, your thoughts down below, and what else could be added to something like this. I personally did not know that Koromoto models were so powerful and were being used in robotics and gait analysis, human clinical studies, and those type of things. But I was quite inspired by some of the talks that I heard at APS March meeting last year and this year. So I was like, let me try this out. I have to try this out for myself, and you know what? It's quite interesting what you can learn about the brain from just watching mice walk. Okay, I'm gonna stop ranting at this point. Feel free to leave me your thoughts and comments below. If you find any bugs, again, please report those to me. I will fix those. These are community resources that are on GitHub, and I would love to keep them up to date so that other people can utilize them too. Thank you so much. Bye bye.